I am going to give you a number so completely detached from everyday human experience that it breaks our ability to intuitively understand it. To give it proper context, we first need to look at the physical boundaries of the observable universe, every single thing that exists across billions of light years of space. Looking at this high-resolution capture of a spiral galaxy gives us a sense of that scale. Scientists estimate that if you count every single atom in every star, planet, and speck of dust across the entire observable universe, you reach roughly 10 to the power of 80. Written out, that is a 1 followed by 0 after 0 after 0, 80 of them in total, stretching across the page. That massive figure represents the absolute ceiling of physical reality. It is the maximum amount of matter available to us. Now shrink your focus entirely away from the cosmos and look down at a standard 64-square wooden chessboard. A mathematician named Claude Shannon once asked a straightforward question: how many unique games of chess can actually be played on this tiny grid? The answer, he calculated, is 10 to the power of 120. We are looking at a mathematical canyon. The difference between those two figures is an exponential gap so severe it defies logic. A basic wooden board holds significantly more potential realities and pathways than there are physical atoms in the universe. The mechanics driving this are incredibly simple. White makes a single opening move, and black has 20 possible responses. This diagram illustrates combinatorial explosion. A single decision fractures into dozens of paths, multiplying into millions of unique board states. By the mid-game, players wander through a mathematical forest so impossibly dense that mapping every branch is a physical impossibility. Even the greatest human grandmasters in history, like Vasily Smyslov, seen analyzing a board here, have only ever explored a microscopic fraction of these paths. Success in this environment requires active pathfinding. Players must navigate a shifting landscape of choices rather than relying on pure memorization. It is highly common today to assume that modern supercomputers or advanced AI have entirely solved this game. Early computer scientists definitely tried. Look at these vintage IBM mainframes. These represent early, massive physical efforts to calculate and store every possible game state. But brute forcing a number like 10 to the power of 120 hits a physical wall. A machine calculating millions of moves per second would run longer than the current lifespan of the universe and still not finish. Even modern engines like Stockfish do not actually know every move. They merely calculate the highest probability path available in the current moment. That mathematical forest remains entirely unconquered. No human or machine has successfully mapped it. Pulling back from all this unconquerable math, look at this photograph of a single child sitting quietly at a table. Here is the central paradox. That young player is actively navigating the exact same infinite math that breaks the world's greatest supercomputers. When they push a pawn into a mid-game attack, they are frequently generating a specific board arrangement that has never occurred in human history. The cognitive demand forces their developing brain to rapidly calculate probabilities, predict incoming threats, and adapt entirely novel strategies on the fly. The game acts as an architectural tool for their mind. It is actively constructing complex neural pathways deep within the brain. Providing your child with the ability to navigate this kind of mathematical landscape is one of the most profound cognitive advantages you can give them. Chessadda is a structured program designed specifically to guide children aged 4 to 16 safely through this complex space. They pair students with expert guides for live online sessions, accessible from anywhere in the world. You can enroll your child today by following the link provided on screen. Their next move is waiting to carve a completely new path into the universe.